Okay, today is Monday, November 3rd, and you're supposed to complete the activity for 1.1.5. A is the last activity, and turn in the completed paperwork for all of 1.1.5. So you have somewhere in a notebook been working on, this is the one we're going to do, 1.1.5a, and these are hand calculations, so you're learning how to do this without multi-sim. And you're using Ohm's law in number 2 to calculate current, voltage, or resistance using V equals IR. We're going to need that. I'll put it here. We did that. You have that down. And then we did series circuits, which I'll run through, and then we did parallel circuit, which we ran through. And there's series and parallel, and then a combination for number 8. So let's do a quick recap. Okay, so series and parallel review first. Series resistance is just the sum of all the resistances. So if I have a 9-volt direct current voltage source like a battery, and I have a 10 ohm and a 20 ohm and a 30 ohm and a 40 ohm resistor, the total resistance is just the sum. So 10 and 20 is 30, 30 and 30 is 60, 60 and 40 is 100 ohms. So that's as easy as that gets. So let's do V equals IR for this one and figure out what the current I is, because we have to figure out the current on all of these. And so V is 9 volts. We're looking for I, and resistance I already said was 100, because it's the sum of, you're adding 10 and 20 and 30 and 40 to get 100. How do you solve this? Well, we've done several of these. You should know from math, you should know from physical science. In this case, you got to get this by itself. Divide both sides by 100 ohms to be equal. Divide this side by 100 ohms. And 9 divided by 100 would be 0.09 amps. Okay. That's easy enough. You probably already know how to do that. We've done several examples like it. Parallel. How do you do it? You can't find the total resistance, you can find 1 over the total resistance. And then the inverse of the total resistance is equal to all of the individual inverses. So if I again have a 9-volt battery, and again have a 10 ohm, 20 ohm, 30 ohm, and 40 ohm resistor, but this time in parallel, some of the current goes here, some of the current goes here, some of the current goes here, some of the current goes here. Remember, we're going to be looking for I, but first we need the total resistance. And the total resistance is 1 over 10 and 1 over 20 and 1 over 30 and 1 over 40. Now, you can, if you can get a common denominator that's simple, do all these with a common denominator. So real quick, I'm going to do that. 1 over RT is equal to, my common denominator is 120. So if I have a tenth, I have 12 over 120. That's a tenth. If I have a 20th, I have 6 over 120. If I have a 30th, I have what? 4 over 120. And if I have a 40th, I have 3 over 120. You're not going to do it this way probably, that's okay. But if I had 6 and 4 and get 10, that's 22. 25 over 120 is 1 over the total resistance. Flip both sides. Which is 120 divided by 25, which is 4.8. 4.8. Now, let's try it the way you're likely to do it. But you can do it that way. This is a little bit of a harder example. You could do it that way quickly without having to use a calculator on some of them that have a common denominator. So 1 over RT, use the calculator. Pick up the calculator. 1 divided by 10 is 0.1. 1 divided by 20 is 0.05. 1 divided by 30 is 0.03. 1 divided by 40 is 0.025. Pretty sure. Okay, so add these guys. Here's where the mistake we kept making last week, and the mistake that's easily made. When you add these together, you don't get RT. You get 1 over RT. Easy mistake to make, but we've already made it several times, so we need to be aware of that. Add these together, we get 0.15 plus 0.0333 plus 0.025 equals 0.2083. Now, take the invert of both sides. So the inverse of that and the inverse of this is RT equals. Now I can invert that. I can take 1 divided by 0.2083. And I get 4.8, which is what I had before. Okay, now you have to solve for I. You've got the total resistance. Let's get the total current also. So if my total resistance is 4.8 ohms, and my voltage is 9.0 volts, I'm looking for I. How do you do it? Get I by itself. Divide this side by 4.8 ohms. But to be equal, you divide this side by 4.8 ohms. You can use a calculator. 9 divided by 4.8 is going to be pretty close to a half, or pretty close to 2. 1.875. I equals 1.875 here. Okay, that's enough review. Let's work one that's just like number 8. But first, let me show you how to do these. You want to, when you have circuits that are mixed parts of series and parallel, combine parts and then redraw. And you'll probably have to redraw a couple of times. These guys here can combine to one large resistor. These guys can combine to one large resistor parallel, and these guys can combine to one large resistor parallel. So if you redrew this, you'd have 9 volts again. And you'd have one resistor for here, and one resistor for here. And over here, you'd have a larger resistor for these 3, and then one resistor here. And then the next thing you would do would be combine these two guys and draw it over. And you'd have a resistor and one resistor for these two, and now you just have a series circuit. Okay, let's do the one that's just like number 8. And then you can do number 8, which will be just like this. And you have to find 2 things. First, the total resistance, then the total current. So I would combine these two and redraw it so you get these 2 series out of the way, and then I would make a parallel. So first I would redraw this 9 volt as a 200, and here I've got a 900 ohm, and here I've got a 400 ohm. I'm going to keep all that, but over here I'm going to combine these two, and they're in series. So when you combine 300 and 500, you get 800 ohms. Now I'm thinking parallel between those two is going to be 850, but let's try it. I got to redraw it first of all. I'm going to have that 200 still, and the 400 still. And what's that? Well, it'd be 1 over 900 plus 1 over 800 is 1 over RT. So 1 over RT, go ahead and divide 1 divided by 900 should be 0.00101, 0.001001, I think. 1 divided by 900, 0.00111111. And 1 over 800 is 0.0025, I think. 1 divided by 800. No, 0.001225. This is like an 8, but with 2 more zeros. Now add that. 1 over RT is 0.00236. That is not RT. It's 1 over RT. So invert both sides. Invert that whole thing, which gives you RT, and invert that. So RT equals 1 divided by 0.00236. Which is 424. Not what I thought it was going to be. And then you just add them. So these two is 824 plus that one is 1024. $424 and 400 is 824 and 1024. So if RT was 1024 ohms and V equals IR, and we have 9 volts, and your resistance is, what did I say, 1024 ohms, we are looking for I. So this is a lot like the one in your book, or the one in your example to do. So I is equal to 9 divided by 1024, which is not very much. .00879 amps for current. Okay, so you're going to do yours similar to this. By the way, this little symbol here in the corner just means you're grounded, which I haven't done yet on these. And it's a certain type of ground. When we get into multi-sim, we'll see that. So do this one, which is just like it. And turn all that in. One paper.